When a motor burns up, several factors could contribute to a resulting explosion. Electric motors typically have varnish-coated windings that provide insulation. If the motor burns, the varnish can vaporize, mixing with air and creating a flammable atmosphere. This vaporized varnish is a primary suspect. Another possibility is hydrogen gas. Motors can release hydrogen gas during normal operation. A disconnect switch creating a spark could ignite accumulated hydrogen in the conduit. The presence of methane gas is another potential cause. In certain environments, such as sewers or biogas facilities, methane gas can accumulate within conduits. A spark could ignite this methane, leading to an explosion. Arcing faults are a fourth possibility. When the electrician turned off the disconnect, it could have caused an arcing fault within the box. This arcing generates enough heat to ignite flammable materials. Fifth, explosive dust is a consideration. Conduits can accumulate dust and debris over time. If the dust is explosive in nature, such as coal dust, a spark could ignite it and cause an explosion. To mitigate the risk of future explosions, several actions should be taken. Firstly, investigate the cause of the motor burn-up to determine if any of the factors previously mentioned contributed to the explosion. Secondly, thoroughly inspect the conduit and box for any signs of damage or explosive residue. Thirdly, consider installing explosion-proof enclosures or ventilation systems to prevent the accumulation of flammable substances. Finally, train electricians on proper lockout tagout procedures to minimize the risk of creating sparks and igniting explosive atmospheres. Focusing on each of these areas can improve electrical safety. Let's delve deeper into each potential cause, starting with volatilized varnish vapors. The varnish used to insulate motor windings is typically composed of organic solvents and resins. When the motor overheats and burns, these components break down and vaporize, creating a complex mixture of volatile organic compounds. These vapors are often heavier than air and can accumulate in low-lying areas, such as the conduit running from the motor pit to the disconnect box. The lower explosive limit, or LEL, of these varnish vapors can be quite low, meaning that only a small concentration in air is needed for ignition. The temperature at which these vapors ignite, known as the auto-ignition temperature, is also relatively low, making them easily ignitable by a spark or hot surface. Next, let's discuss hydrogen gas. Hydrogen can be produced in electric motors through several mechanisms, including the electrolysis of moisture within the motor and the decomposition of lubricating oil at high temperatures. While the amount of hydrogen produced may be small, it can accumulate in confined spaces such as conduits. Hydrogen has a very wide explosive range, meaning that it can ignite at concentrations as low as 4% and as high as 75% in air. This makes it a particularly dangerous gas to have present in an electrical enclosure. Furthermore, hydrogen has a very low ignition energy, meaning that only a small amount of energy is needed to ignite it. This makes it susceptible to ignition from even small sparks. Methane gas is another potential hazard, especially in environments where organic matter is present. Methane is a byproduct of anaerobic decomposition and can be found in sewers, landfills, and biogas facilities. If the conduit runs through or near such an environment, methane can seep into the conduit system. Methane has a lower explosive limit of around 5% in air and an auto-ignition temperature of around 1000 degrees Fahrenheit. While its ignition energy is higher than that of hydrogen, it can still be easily ignited by a spark or hot surface. An arcing fault is a dangerous electrical phenomenon that can occur when there is a breakdown in insulation or a short circuit. When an arcing fault occurs, a large amount of energy is released in a small area, creating a very high temperature plasma. This plasma can easily ignite flammable materials in the vicinity. In the case of the motor disconnect box, an arcing fault could have occurred when the electrician turned off the disconnect switch. This could have been due to a loose connection, corroded contacts, or a buildup of conductive dust. The arcing fault could have generated enough heat to ignite any flammable vapors or dust present in the box. Explosive dust can accumulate in conduits over time, especially in industrial environments where dust is generated by manufacturing processes. Many types of dust are explosive, including coal dust, grain dust, wood dust, and metal dust. The explosivity of a dust depends on several factors, including its particle size, moisture content, and chemical composition. When explosive dust is suspended in air to sufficient concentration, it can be ignited by a spark or hot surface, resulting in a dust explosion. Dust explosions can be very powerful and destructive, as the rapid combustion of the dust creates a large pressure wave. Now let's move on to the recommended actions to prevent future explosions. Firstly, a thorough investigation of the motor burn-up is essential to determine the root cause of the failure. This investigation should include a visual inspection of the motor windings, insulation, and bearings. The motor should also be tested for insulation resistance, winding impedance, and other electrical parameters. The investigation should also include an analysis of the environment in which the motor was operating, including the presence of flammable gases or dust. The results of this investigation can help to identify the most likely cause of the explosion and to implement appropriate preventive measures. Secondly, a thorough inspection of the conduit and disconnect box is necessary to identify any signs of damage or explosive residue. This inspection should include a visual examination of the conduit for cracks, corrosion, or other defects. The disconnect box should be inspected for signs of arcing, overheating, or contamination. Any residue found in the conduit or box should be collected and analyzed to determine its composition. The results of this inspection can help to identify potential sources of ignition and to assess the extent of the damage caused by the explosion. Thirdly, the installation of explosion-proof enclosures or ventilation systems may be necessary to prevent the accumulation of flammable substances. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure, preventing it from propagating to the surrounding environment. Ventilation systems can be used to remove flammable gases or dust from the enclosure, preventing them from reaching explosive concentrations. The selection of the appropriate enclosure or ventilation system will depend on the specific environment and the types of flammable substances that are present. Finally, it is essential to train electricians on proper lockout tagout procedures to minimize the risk of creating sparks and igniting explosive atmospheres. Lockout tagout procedures are designed to ensure that electrical equipment is de-energized and isolated before any work is performed on it. These procedures typically involve disconnecting the equipment from its power source, locking out the disconnect switch, and tagging the switch to indicate that the equipment is out of service. Proper lockout tagout procedures can prevent accidental energization of the equipment, which can lead to sparks and explosions. In addition to these specific actions, it is also important to implement a comprehensive electrical safety program. This program should include regular inspections of electrical equipment, preventive maintenance procedures, and ongoing training for electricians and other personnel who work with electricity. By taking these steps, you can significantly reduce the risk of electrical explosions and create a safer working environment. It is also important to note that the National Electrical Code, or NEC, provides detailed requirements for electrical installations in hazardous locations. Hazardous locations are defined as areas where flammable gases, vapors, or dusts are present or may be present in sufficient quantities to create a fire or explosion hazard. The NEC requires that electrical equipment installed in hazardous locations be specifically designed and approved for use in those locations. This equipment is typically more robust and explosion-proof than standard electrical equipment. When working in or around hazardous locations, it is essential to be aware of the specific requirements of the NEC and to follow all applicable safety procedures. Neglecting these procedures can have serious consequences, including explosions, fires, and injuries. Let's examine some specific scenarios. Firstly, consider a scenario where the motor is located in a wastewater treatment plant. Wastewater treatment plants often contain methane gas, which is produced by the decomposition of organic matter. If the motor is not explosion-proof and methane seeps into the motor or the conduit system, a spark could ignite the methane and cause an explosion. In this case, it would be essential to install an explosion-proof motor and to ensure that the conduit system is properly sealed to prevent methane from entering. Secondly, consider a scenario where the motor is used to drive a grain elevator in a farm. Grain elevators can generate large amounts of grain dust, which is highly explosive. If the motor is not properly enclosed and grain dust accumulates on the motor windings or in the conduit system, a spark could ignite the dust and cause a dust explosion. In this case, it would be essential to install a totally enclosed fan-cooled, or TEFC, motor and to regularly clean the motor and conduit system to remove any accumulated dust. Thirdly, consider a scenario where the motor is located in a chemical plant. Chemical plants often use flammable solvents and other hazardous chemicals. If the motor is not explosion-proof and these chemicals leak into the motor or the conduit system, a spark could ignite the chemicals and cause an explosion. In this case, it would be essential to install an explosion-proof motor that is specifically designed for use with the chemicals present in the plant. Furthermore, it's crucial to establish a culture of safety within your organization. Regularly communicate the importance of electrical safety to all employees and encourage them to report any potential hazards or concerns. Conduct regular safety meetings and training sessions to reinforce safety procedures and to provide employees with the knowledge and skills they need to work safely. Invest in high-quality electrical equipment and safety gear, and ensure that all equipment is properly maintained and inspected. By creating a culture of safety, you can empower employees to take ownership of their safety and to work together to prevent accidents. In summary, electrical explosions are a serious hazard that can have devastating consequences. By understanding the potential causes of explosions and by implementing appropriate preventive measures, you can significantly reduce the risk of these events. Remember to investigate all motor burnouts, inspect conduits and boxes, consider explosion-proof enclosures and ventilation systems, and train electricians on proper lockout-tagout procedures. Adhering to the National Electrical Code and establishing a culture of safety are also crucial for preventing electrical explosions. By taking these steps, you can create a safer working environment for yourself and your colleagues. Furthermore, always consult with qualified electrical engineers and safety professionals when designing and installing electrical systems in hazardous locations. These experts can provide valuable guidance on selecting the appropriate equipment and implementing the necessary safety measures. They can also conduct hazard assessments to identify potential risks and to develop strategies to mitigate those risks. Remember that electrical safety is an ongoing process that requires continuous vigilance and attention to detail. Do not become complacent or take shortcuts, as even a small mistake can have serious consequences. By staying informed, following safety procedures, and working together, you can prevent electrical explosions and create a safer and more productive workplace. Remember, safety is everyone's responsibility. Always prioritize safety in all of your electrical work, and encourage others to do the same. Together, you can create a culture of safety that protects everyone from the hazards of electricity.